Angular momentum conserved in central force field. Angular momentum conserved in central force field. Central force field. Consider a particle of reduced mass m moving about the origin O. The force acting on the particle is a central force. It is therefore given by vector F. Vector F equal to vector F function R, unit vector R, where R is the unit vector along the direction vector R, and vector R is the position vector of the mass m. The torque acting on a particle subjected to a central force is 0. The torque acting on a particle subjected to a central force, subjected to a central force is 0. This is proved as under. Torque is defined as the vector product. Vector R cross vector F, where vector F is the force acting on the particle, where vector F is the force acting on the particle, and vector R its vector distance from the origin, and vector R its vector distance from the origin. This is the This is the x-axis. This is the y-axis, and this is the z-axis, and this is the unit vector R and position vector R, and this is the particle m. Then angular momentum conserved in central force field. Consider a particle of reduced mass m. Consider a particle of reduced mass m moving about the origin O. The force acting on the particle is a central force. It defined as given by vector F. Vector F equal to F function of R, unit vector R, where unit vector R is the unit vector R along the direction of vector R, and the direction of where unit vector R is unit vector along the direction of vector R, and vector R is the position vector of the mass m. The torque acting on a particle subjected to a central force is 0. This proved as under. Torque is defined as the vector product of vector R and vector F. Where F is the force acting on a particle, and vector R is the vector distance from the origin. Then torque tau equal to vector R cross vector F equal to mod of vector R unit vector R cross F R function unit vector r. Then the value is mod of vector r f r in unit vector r cross unit vector r equal to 0. Now torque is the time rate of change of angular momentum j. Now torque tau is the time rate of change of angular momentum j. Then tau equal to dj vector upon dt. If tau equal to 0, then dj vector upon dt equal to 0 or j equal to a constant. Hence the angular momentum of particle hence the angular momentum of a particle under a central force always remains constant. Under a central force always remains constant. And is therefore a constant of motion. In other words, in a central force filled the angular momentum. Angular momentum of a particle is conserved. Particle is conserved. Okay, thank you.